Okay, this is just a quick video talking about number two. So I was missing one key thing. For those of you who are just watching this video and saying, what the heck are you talking about? It will be this particular problem. So it's chapter 9-5, 9-6, number two, which is this one. A regular transition matrix is defined by this. We got a steady state probability vector, and we need to solve for u by solving a system of equations. All right. Now, everything that I did was actually correct, but I was missing one key thing. This part was absolutely wrong, so let me get rid of that part. Okay. Everything up to this point was correct. So you take the transition matrix, you multiply it by that. You are supposed to turn it into a system of equations. I actually had to think about it for a bit, but there was one key thing that I was missing. You subtract u sub 1, subtract u sub 2, you subtract u sub 3. Yes, this part was fine. Setting it up like this was fine. There was one key piece of information that I was missing, and that was this. U is a steady state probability vector, meaning there's one more hidden equation in here. And it's nowhere in the book and stuff, obviously, but it didn't occur to me to actually use this until I was thinking about it. I was like, wait, there's one thing I'm missing here, and that is this. U sub 1 plus u sub 2 plus u sub 3 equals 1. All three of these probabilities have to add up to 1. Okay? So we need one more little thingy here, and that is this. U sub 1 plus u sub 2 plus u sub 3 equals 1. You won't find this in the book. Okay? You need this. Now, the reason we were having problems is because we got this 0 column matrix on the right. That's kind of an issue. So what I'm going to do is I'm actually going to add this equation to all three of these rows. That will get rid of this 0 matrix right here. And it'll solve this problem. This problem is that this matrix right here, the determinant of it is 0, and that means that it doesn't actually have an inverse, which is a problem. But when you take advantage of this one fact, which is that u1 plus u2 plus u3 equals 1, then I can just add, basically, if you look at here, I'm going to add u1 here, add u2 here, and add u3 here. In fact, why don't I just start with this system of equations right here. I'm going to add this equation to all three of these. Okay. So when I do that, negative 0.19 is just going to turn into positive 0.81. Whoops. That one. 0.1 is going to turn into 1.1. 0.08 is going to turn into 1.08, and this will turn into 1. So all I did was I just took u1, u2, u3, and I added it right here. And that's going to turn into this thing. So you just add one to that, add one to that, add one to that. And of course, there's a 1 on the end. Now you want to do the same thing to this equation right here. I admit this problem is a little bit harder than I originally remembered. It took me a second to remember what I did to actually get the right answer, but there's a hidden factoid. So if I do it again for the second one, you just add 1 back in for all of these. And the last one, you add 1 to this last one right here. This turns back into 0.42 and a 1. Whoa. Where'd my plus sign go? There it is. I'm going to be honest, I don't imagine you're going to see anything this hard on the IB exam. But it's still good to know how to do it. So this is one fact that we have to take advantage of, and we have to add it back into here. Now, we can take this system of equations and solve that, because this will actually have an inverse now. So 0.81, 1.1, 1.08, and 1.09, 0.15, 1.5, 1.1, 1.75, 0.42. Cool. And then on the right, instead of zeros and zeros, we're just going to have ones. So now that is solvable. Okay. That one we can actually do. So scrolling down a little bit, let's take this. We're going to left multiply by the inverse. -1. And left multiply by the inverse. So you just left multiply by the inverse of this particular matrix, and the nice thing about doing that, as we all know, is that all of these things cancel out. Cool. And now we are left with, quite simply, this. This one we can plug into our calculator and get the final answer. So alpha F3, we're going to need a 3x3 matrix. Cool, 0.81, 1.1, 1.08, then 1.09. I'm just copying this matrix down. 0.15 and 1.5. This, whoa. This will be 1.1, 1.75, 0.42, and we're going to raise this to the -1 power to indicate an inverse. Now I'm going to multiply it by a 3x1 matrix with just ones. 1, 1, 1. That is the answer. That's it. So 0.32, 0.27, and 0.41. So that was the one thing I was missing. I forgot all about this particular problem, which was this. I need to remember that it's a steady state probability vector. And that means that there's one more equation that I needed to utilize, which I completely blanked out on, which was this. U1 plus U2 plus U3 equals 1. You can put those back into this matrix, into the system of equations, and solve a brand new system of equations to get your final answer, which is 0.32, 0.27, and 0.41. There's no way you would have been able to do that with just the material out of the book. This problem was really designed for the teacher to be able to give it to you, and I completely forgot about that little fact, so sorry about that. Anyway, good job. Hope this video finds you well, and I'll see you later. Bye-bye.